Hey guys, today we're gonna represent one of the most important gas laws done by Hagar Ihab, Dina Tariq, Shams Faiz, Noura, and Numrusi.
Gases, variable volume and shape. Expand to occupy volume a variable. Volume, pressure, temperature, and the number of moles present and integrated can be easily composed. Expert pressure on whether surrounded them, easily diffuse into another. First, we have a lot of gases laws. Let's explain each one. Let's first talk about the first scientist. The first scientist, Robert Boyle. Robert Boyle was born 25 January 1627, Ireland, Lismore Castle. He died at the age of 64, 31 December 1691 at London. He was one of the most important scientists that did work at the gases law.
Now we are going to talk about Boyle's law.
According to Boyle's law, the pressure and volume of gas are inversely proportional at a constant pressure. That means PV equal constant, and the rule is P1 V1 equal P2 V2. Let's have a little example to make it clear and simple. A sample of gas occupies 344 centimeters at a pressure of 77.8 kPa. What will the volume be at 23.35 kPa? P1 V1 equal P2 V2. P1, we're gonna write 77.8 multiplies 344 equals 23.35 times V2. Let's now multiply P1 and V1. It will end up to 6.763.2 centimeters and kPa equals 23.35 times V2. We are going to take P2 and we're gonna divide the whole equation with it, and we'll end up having V2 equal 1.146.2.
Now here is the second scientist, Charles
Law. The scientist Jacques Charles, he was born 12 November 1746. He died at the age 76, 17 April 1823. According to Charles' law, the volume of gas is proportional to Kelvin temperature as long as the pressure is constant. V is constant. V equal kT, and this is the rule.
Then we have a small example, which is a bubble of air trapped in a pool of water, and it has a volume of 1.20 centimeter at 24 C. Calculate the temperature in Celsius of the air bubble when the volume become 1.26 centimeter. We're gonna make B1 over T1, which is equal to V2 over T2, and we're gonna substitute it by the numbers they gave us in the question, which is 1.2 over 24 plus 273 equal 1.26 over T2. We're gonna get the answer, which is 331.85, and K is gonna be equal 38.85 C.
And now I'm going to talk about the last two scientists. The first one, which is Joseph Louis Gay. He was born in 6 December 1778 and died at May 9, 1850. His age was 71 when he died. The pressure of gas is directly proportional to the Kelvin temperature if the volume and the amount of gas is kept constant. And the rule is P1 times T1 equals P2 T2, which means P1 over T1 and P2 over T2.
The last one is Avogadro's law. The pressure of gas is directly proportional to the number of moles of the volume and temperature as kept constant. The rule says V1 N2 equal V2 N1, which means V1 over N1 will V2 over N2.
Those are the scientists that did work about gas law. Now we are going to move what did happen after gas law, after the scientists find those rules. Okay, guys?
And now I'm going to talk about the combined gas law, which is the combined gas law was mixed by the rule of Charles and Boyle's law, and also the temperature-pressure relationship in one equation, which is V1 P1 T2 equals V2 P2 T1, which is also P1 V1 over T1 and P2 V2 over T2.
After we talked about the combined gas law, we're gonna move to the ideal gas law. The ideal gas law relates the pressure, temperature, volume, and the amount of gas through the gas constant, which is R. Then we have the ideal gas law. It relates to Boyle's law, Charles' law, and Avogadro's law. And then we have the law itself. It's PV equal nRT. The ideal gas law represents P. We have P first, which is pressure in ATM. Then we move to the volume. It's in liters. Then we have N, which is moles. And then we have R. It's the proportionality constant, which is 0.08